Good morning children, this is Latha. Welcome to class 6 IIT Physics class. So what we are doing, we are discussing equations of motion. Is it not children? We already started equations of motion. So what is our topic? Equations of motion. So we will discuss three important equations of motion what going to help you a lot in the higher classes. Okay na children? So already in the previous class we discussed first equation of motion. So what was the first equation of motion? First equation of motion, that is V is equal to U plus AT, or velocity time relation. The first equation of motion brings the relation between velocity and time. V is equal to U plus AT, where U is the initial velocity of the body, V is final velocity of the body, A is acceleration, it's a uniform acceleration, T is time. So remember children, these three equations of motion what you studied already in the previous class, today second equation of motion, and in the next class third equation of motion. These three equations of motions are applied only for a body which is moving with either uniform acceleration or uniform retardation. Very important point, you have to remember this one, that these three equations of motion will be applied only for a body which is moving with uniform acceleration or uniform retardation. Clear? So what was the first equation of motion? Velocity time relation, that is V is equal to U plus AT. Okay now? So today in today's class we are going to discuss about the second equation of motion, that is S is equal to UT plus half AT square, and this relation is known as displacement time relation. Clear? So the second equation of motion brings the relation between displacement and time. So S stands for displacement. S stands for displacement. Clear children? S is equal to UT plus half AT square. What is U? Initial velocity, T is time, A is uniform acceleration. Clear? So let's start the derivation for second equation of motion. So suppose a body, okay, its initial velocity or starting velocity is U. Okay, a body whose initial velocity or starting velocity is U, and it is moving with uniform acceleration, that is A. We know that these equations of motion only applied for the bodies which are moving with either uniform acceleration or uniform retardation. If it is uniform retardation, then A will be changed to minus A. Clear? Next, time is T and final velocity. The final velocity of the body is V. Okay now? These terms are very clear. Body, its initial velocity U, uniform acceleration A, then time T and final velocity V. So let the displacement of moving body in time be S. Body is moving, a body, its initial velocity is U, it is moving with a uniform acceleration A, and in time T it moved and its final velocity is V. From U initial velocity U to final velocity V, in time T with uniform acceleration A, it covered some displacement. So what is displacement? That is S. What is displacement here? Displacement is S. Okay. So displacement of a moving body is moving, it moved, okay, in time T seconds. How much displacement? S. So in displacement of a moving body, how can you find? We can find out by considering its average velocity. So how to find average velocity? Let's see. So before erasing, please write down, children. Once again I will tell you, take your notes, write today's subject, date, time neatly, and the heading IIT Physics. What is the chapter? Equations of motion. Okay. First write down this. While writing from the board, please pause the video and completely write from board. After writing only, you continue the video. Okay. So once again I want to tell you, children, you have to watch the video minimum 2 to 3 times till end. Then only you can understand the concepts. You have to watch the video till end 2 to 3 times. And whatever explained in the class, you have to practice it. Then only it will be easy for you. Very soon you have exam. Okay. And the chapter is, the syllabus is first chapter measurement, first 3 concepts. You have to prepare for that. Okay. So overwriting. Okay. So you'll erase this. So children, now what we have to do? We have to find average velocity. Average velocity. Average velocity is equal to what? Average velocity, how to find? Children, we already discussed velocity and average velocity. Okay, so once again remind yourself, average velocity is what? Initial velocity plus final velocity whole divided by 2. Is it now? Average velocity is equal to initial velocity u plus final velocity v by 2. Okay, average velocity is equal to initial velocity plus final velocity whole divided by 2. Now displacement is equal to what? Average velocity into time. Is it no, children? Yes or no? Displacement is equal to what? Displacement is denoted by S is equal to average velocity into time. Average velocity, how much we got here? Average velocity is equal to u plus v by 2 into time is t. Is it no, children? Any doubt? What is S? S is displacement. What is u plus v by 2? It's average velocity. We already calculated. Average velocity is u plus v by 2. So in place of average velocity, u plus v by 2. Okay. Into time t. Clear? Now, by first equation of motion. So here I hope you have written this one. Shall I erase this? Okay. By first equation of motion, v is equal to what? V is equal to u plus at. Is it now? According to first equation of motion, velocity time relation, v is equal to u plus at. So u plus v place what we will write? U plus at. Okay, according to first equation of motion, v is equal to u plus at. So in place of v, u plus at whole by 2 into t. Now u plus u, 2u plus at by 2 into t. Okay, we have to simplify here. So you see, children, t is multiplied by this term also and t is multiplied by this term also. So when we remove the bracket, 2u by 2 into t plus at by 2 into t. Clear, children? Very clear? T is multiplied by both 2u into t, at into t. And when you separate this, So 2u by 2, at by 2. Clear? So 2u by 2 into t, at by 2 into t. Now 2 cancel. What is left? Ut. First term plus. Here what? 80 into t, 80 square. And by 2 is there. So half we will take it front. Half into 80 square. So therefore S is equal to what? Ut plus half 80 square. That is our second equation of motion. What is second equation of motion? Displacement time relation. Okay children, I hope you are understanding. Displacement of a moving body we can find by finding its average velocity. Average velocity is equal to what? Initial velocity plus final velocity by 2. U plus V by 2. That is average velocity. Displacement is equal to what? Displacement is equal to average velocity into time. Displacement denoted by S. Average velocity equal to U plus V by 2 into time t. According to first equation of motion, V is equal to U plus AT. So in place of V, what is written? U plus AT. Okay, now we have to simplify it. Whole is multiplied by t. So u into t, ut. Before it, we had to add this u plus u, 2u plus at whole divided by 2 into t. Okay, simplify it. How much we got? Ut plus half at square. That is our second equation of motion. Displacement time relation. S is equal to, what is S? Displacement is equal to ut plus half at square. Okay children, please write on this. Now children, the second equation of motion, that is displacement time relation. S is equal to ut plus half at square. Based on the second equation of motion, we will do one sum. Okay, so you can see a sum on the board. So let's see. A motor boat starting from rest. Okay, remember what? Boat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square. Okay, acceleration is given. Constant rate, it means what? This is uniform acceleration. Okay now children, you have to remember what? The three equation of motion here applied only for the bodies which moves with uniform acceleration or uniform retardation. Okay, so uniform rate is what? 3 meter per second square. For time 8 seconds. Time also given 8 seconds. Acceleration is given. Time is given. How far does the boat travel during this time? You have to find how far does the boat travel. Means you have to find its displacement. Clear now? What you have to find here? Displacement you have to find here. So let's do this sum. Okay. So the first thing, when already we discussed, whenever a body starts from rest, means not moving. Body is in rest means not moving. So velocity is 0. So when it starts from rest, its initial velocity 0. Whenever a body starts from rest, its initial velocity 0. When a moving body comes to rest, its final velocity 0. Okay, now whenever a moving body is moving, it stopped now, comes to rest, so its final velocity will be 0. So here motor boat starting from rest, so its initial velocity is what? 0 meter per second initial velocity. Again what is given? Uniform acceleration is given. uniform acceleration 3 meter per second square. Again, what is given? Time is given. Time is 8 seconds. What you have to find? How far does the boat travel during this time? You have to find displacement. Displacement. You have to find here displacement. S question mark. So, by second equation of motion. What is second equation of motion known as? Second equation of motion known as displacement time relation. It brings relation between displacement and time, that is S equal to ut plus half at square. Displacement S is equal to u. What is u? U is 0. Initial velocity is 0. 0 into time plus half into 8t square. How much acceleration? 3 into time. How much? 8 seconds. 8 into 8. Now first term becomes 0. 0 into t, 0. First term is 0. Then cancel. 2 4 ja 8. So 4 3 ja 12. 8 ja 96. Therefore, S equal to 96. What is S? Displacement is equal to 96 unit meter. All are in the SI unit. Meter per second square, seconds. All are in SI unit. So your answer also in SI unit. Okay, now this thing you have to remember. Unit, system of units are very important. You must remember. So the given quantities are in which system. So that only depends in which system of unit you will get the answer. Clear, children? So once again, a motor boat starts from rest. As it starts from rest, its initial velocity is 0. U is 0 here. On a lake, accelerates in a straight line at a constant rate. Constant rate means uniform acceleration 3 meter per second square. For time is 8 seconds. How far does the boat travel during this time? So what you had to find? Displacement you had to find. So you had to find displacement means you had to use second equation of motion. According to second equation of motion, that brings the relation between displacement and time is S equal to ut plus half at square. So all the required details we have, you have to substitute and you will get the displacement 96 meter. Very easy sum. We will do again this type of sums in the next classes. Okay, children. So this is for today. Today what we learned? Second equation of motion, and we did one sum, a basic sum on the second equation of motion. Okay, children. I hope you are doing well, doing the worksheets, reading the reading content. Once again, very soon you have exam. You have to prepare for your exam. First chapter, 3 concepts. First 3 concepts are your syllabus for the online test one. Okay, now? So this is for today. Thanks for watching.